Cutting fluid swerve treatment system for inorganic glass. The cutting fluid during the lens generator processing is conveyed through pipelines to the sewage pump station. The cutting fluid wastewater enters the sewage tank within the centralized control water tank. It is conveyed to the scraper centrifuge by the centrifuge water supply pump. One water supply pump is on standby and the other is in use. The cutting fluid is bled onto the high-speed rotating drum. Centrifugal force causes solid impurities to adhere to the drum's inner wall. The filtered cutting fluid is flung back into the sewage tank. When impurity accumulate inside the drum, the centrifuge automatically initiates the slag discharge program. The scraper will automatically move to the inner wall of the drum, removing impurities and discharging them. The discharged residue falls into the slag collection cart at the bottom. Water is introduced again to clean the residual slag, and the wash water returns to the sewage tank. The centrifuge is equipped with a vibration monitoring system that triggers an alarm if limits are exceeded. Cutting fluid is pumped from the sewage tank through a plate filter. The cutting fluid filtered by the plate filter enters the clean water tank. The cooling coil inside the clean water tank is connected to an external chiller. This maintains the water temperature of the entire circulation system within a proper range. The clean water tank supplies the lens generator via a clean water pump. Auto adjustment of cutting fluid pressure based on the quantity of lens generators in use. The unused cutting fluid returns to the clean water tank. Clean water pumps, one duty, one standby. The system's water level is monitored in real time. Automatic replenishment occurs when levels are low and stops at the optimal level. An alarm activates if the water level becomes excessively high. Cutting fluid and deformer are automatically added based on concentration sensors. Cutting fluid swerve treatment system for organic glass. For example, PC resin for the coarse production filament residue. The full system includes a coarse slag filter and an automatic waste residue briquetting machine. Cutting fluid wastewater is directed to a coarse residue filter via pipes. The coarse residue filter uses an internal perforated screen plate to remove large particles of coarse residue. A brush scraper gradually removes the coarse residue. The coarse residue is discharged into a briquette machine's hopper. The coarse residue in the hopper is monitored by a level sensor. The briquetting process starts when the set amount is reached. The compression rod begins to extend for pressing the block. After reaching the set pressure and maintaining the pressure, the material block is discharged. A stirring device in the hopper breaks up the coarse residue. The screw feeder delivers coarse residue into the compression chamber of the briquetting machine. The briquetting machine performs the briquetting process, and the squeezed-out cutting fluid flows into the collection unit. The briquetting process is completed. The discharge door opens, and the main cylinder extends to eject the finished briquette into the collection cart. The discharge door closes, and the cycle repeats for the next batch. The cutting fluid extruded during briquetting flows into the collection unit. Once the float ball in the collection tank detects the preset water level, the sewage pump will transfer the cutting fluid to the wastewater tank for secondary filtration. The hydraulic oil filter requires regular replacement when pressure is high.